let's talk about lecture 19, the MapReduce framework. So the relational database are powerful, which allows us to store, manage, and analyze large database. Some data analyze applications go beyond such system. For example, we have the web pages where the graph of all relevant HTML pages of the network. We can rank the pages by the importance based on which is the basis of the Google search. An iterated matrix product where the number of rows is equal to the number of pages, where we want to find the patterns in the large databases, such like the predictive maintenance, which part of the system are more likely to fail or cause certain effects, learn from the sensor data and infrastructure data, and detect the interesting patterns where the interesting phenomena in space, the earth, and the underwater in salt market. We can recognize the place with certain disease. We can establish the likelihood of archaeology artifacts at a certain site based on the archaeological data, geological parameters, understand the structural dynamics of large networks such as train networks, social networks. Such problem can be solved as divide and conquer algorithm. Thinking pattern where we divide the huge data set and combine the results. This is the idea behind the MapReduce. The MapReduce is a programming framework which provides simple means to create programs that can scale to terabytes of data. Users only implement two methods. It's actually the map and reduce. The map is the computation of the smaller chunk of data, and reduce is how the results are combined to the final results. The MapReduce manages the rest. The MapReduce is Google's original implementation, and Apache Hadoop is open source. So, for example, let's count the word in a document. The text is given a collection of not too large text file, and the task is for each word W count how many words occurs in these files. How to do this in MapReduce? The MapReduce computation is we form a key value pair where it's we go to the MapReduce computation. We go to the word count 1, word 2 count 2, word 3 count 3, and word m count m. To implement this computation, we need to write two functions, which is map and reduce. The map function is that is applied in a single key and value pair and produce a list of non-zero or more keys value pairs. The map, the file path, and the string contents. For each word in the content, output pair W1. For example, the file 1 text hello world, hello UK, hello Liverpool. We go to map algorithm. We get the hello 1, word 1, hello 2, UK 2, and hello 1, Liverpool 1, and then we grouping. After the mapping function has been applied, we group all keys by go values by key. For example, we get the hello for 3 ones, and word for 1, UK for 1, Liverpool for 1. And this is the list of values for keys input for the reduce. The reduce function takes the key and the list of values as input and output as a list of key value pairs. For example, the reduce string words iterate string values. Int count equals to 0 for each way in values. Count equals to count plus phase int way. Output pair word to string count. It's just like to reduce hello 111 output hello 3. We put things together. For example, we text 1 hello world hello, text 2 UK, text 3 hello Liverpool, and we get the corresponding hello world hello UK hello 1 Liverpool 1, and we grouping together with hello, and the word is two of them combining together, and hello 1 Liverpool 1 and hello hello 111 World UK Liverpool. So the beauty of it is that we only have to implement these two functions: the map string file path, string content for each word w in content output pair w1 and reduce, where we put the string word, iterate string values in int count equals to 0. For each way in values, count equals to count plus pass into way, output pair word to string count. The map reduce takes care of everything else. And for example, the parallel execution, including the location of the map and reduce matches. And then we come to the matrix multiplication. The matrix multiplication, given R and S and S and T, the matrix M and N respectively, we can compute the PIK, which is summation of MIJ, NJK. The P can be computed in O of n to the power 2.373 for n equals to R equals to S equals to N equals to the earliest and also fastest for the MapReduce. Use two MapReduce computation. So firstly, we find first the MapReduce, the matrix M and N and the triple list Z plus times Z plus times R. I'm not sure what is this mean. And then the mapping algorithm, the map string matrix string triplet that IJV equals to triplet. If the matrix equals to n, then output the pair of I, comma parentheses n ngv, else output gmiv. The reduce algorithm is int number of iterator string values for each ijk in values. If I equals to m, then for each j prime I prime, j prime, k prime in values. If I prime equals to n, then output the pair. The second map reduce is map pair int pair double number, output pair number. The reduce is pair int pair iterator double north. The double result equals 0 for. I cannot understand that. I just maybe it takes more time. And the relational algebra is that to use the MapReduce to implement the relational algebra. The tuples in R is like R, attribute 1, value 1, attribute 2, value 2. The input is TT, where T is some tuple. For example, we can selection R in C, we can natural join R and S. And we can selection R from C, where we can do the map and the reduce. Similar to everything but the joins and the directions are different. The map does all the work. The natural join is still the same. So for the distributed file system, the MapReduce operates on a distributed file system, similar to distributed database management system. All the data is distributed over all the nodes and sites. Replication are used for the fault tolerance and appears to the user as if it was a regular file system. For example, a Google file system, a Hadoop file system. The inputs to a MapReduce program. The input files to a MapReduce program can be very large, gigabytes. The collection of the web pages, the links of social networks, the Twitter feeds, the stock markets, satellite images, data from scientific experiment. The MapReduce splits this into chunks and provides the ID for each chunk. And for the MapReduce computation, we can get the keys and value pairs and do the MapReduce algorithm. We can get the key prime and the values prime. The keys and values are arbitrary objects. The keys are typically small, values are longer for each MapReduce computation is expressed in two functions, map and reduce. The map1 is the string and the values, return the list of keys and values. The reduce is the string key and iterator string values. It returns the list of keys and value pairs. In practice, also some additional code, for example, the location of the input and output file. Yeah, definitely. And the turning method, that's the number of machines, how many maps, how many reduce tasks. And the execution one is that the chunk 1, chunk 2 go to a map, and we get intermediate result, we can reduce them. And the expressiveness is that MapReduce can be used to compute a number of interesting functions on large databases. We can invert the index for each word, return the list of all documents that it contains it. The operator of relational algebra, we can do the MapReduce can be used to compute a number of interesting functions on large data sets. For example, we can invert the index. The inverted index for each word returns the list of all documents containing it, and we can operators of relational algebra. We can do the matrix multiplication. The MapReduce is not universal parallelism framework. Not every problem that is parallel can be expressed and solved nicely in the MapReduce. The bottleneck is the communication and the disk access. And in summary, the MapReduce is a framework to solving problems on a large volume of data. It can have simple implementation. The MapReduce, the map takes care of the MapReduce takes care of the care, and many interesting problems can be solved in MapReduce.